For most school administrators, the IT budget is a source of constant friction. You watch funds disappear into annual software licenses, while students are left working on sluggish, aging hardware that struggles to keep up with basic lessons. There is a way to break this cycle without an immediate, massive overhaul. By launching a small, controlled pilot program, you can test a more efficient operating system, Linux, to see if it meets your school's actual needs. This trial requires very little to start, just 3 of your slowest computers, a USB drive, and basic network access. Starting with only 3 machines keeps the risk at 0. It allows you to gather real-world data on how much money you can save and how many older devices you can return to the classroom. Step 1 is establishing your baseline. You need to identify exactly what this transition could mean for your school's bottom line. As this chart shows, a standard operating system consumes a massive amount of hardware power just to stay running. Linux requires up to 40% fewer resources, leaving more memory and processing power for the student's work. By reducing that internal strain, you extend the physical life of your current hardware. Computers that currently feel dead can remain in use for an additional 3 to 5 years. This extension changes your budget. Money that used to be locked into annual antivirus and OS licensing can now be redirected into student scholarships or new laboratory equipment. For step 2, go to your storage and pull out 3 computers you were planning to replace this year. Select your most outdated machines. The goal of this pilot is to see if Linux can make your worst hardware perform like a modern tool. If you can prove that these discarded machines are still capable of supporting a student, you prove that technology upgrades don't always require a massive capital investment. Step 3 focuses on software. This is where you address the concern that moving away from traditional systems will break the school's existing workflow. An audit of modern schoolwork shows that 95% of tasks, like research and writing, now happen entirely in the cloud. Because programs like Google Classroom and Moodle run inside a standard web browser, they look and behave exactly the same on Linux as they do on any other system. For the few tasks that happen offline, you will install the LibreOffice suite on the trial machines. LibreOffice is built to handle standard file formats. It allows students to open, edit, and save documents in common formats like .docx, providing a functional bridge for those who still need to work without an internet connection. By ensuring both cloud access and document compatibility, you remove the most common technical hurdles for both students and teachers. Step 4 is the live test. Place these 3 machines in a common area and let students use them without a formal introduction to the new system. Modern educational versions of Linux are designed with this familiar layout. With a standard taskbar and app menu, most users find their way to the browser or word processor without needing a manual. The navigation is as intuitive as a smartphone. Students can typically begin their assignments immediately, requiring almost no retraining. Step 5 is where you track your metrics. Run the trial for 1 week and keep a strict log of every support request that comes from these 3 machines. Linux systems are inherently more resistant to the viruses that typically slow down school networks. They also lack the heavy, forced background updates that often lead to mid-lesson crashes. Historically, schools implementing this architecture have seen support calls for these devices drop by up to 80%. Your pilot will show if your own hardware sees a similar increase in stability. Achieving this level of reliability on machines you were about to throw away is the evidence you need to show your board that a wider rollout is viable. At the end of the week, check your results. You have likely rescued 3 computers, avoided licensing fees, and provided students with a faster, more stable way to work. These results take the conversation from what if to a proven reality. You have the data on speed, security, and software compatibility. Now you can take what you learned from these 3 machines and apply it to an entire lab or a specific grade level. This shift does more than save your budget. It prepares students for a professional world where the majority of the planet's critical servers and infrastructure run quite literally on Linux.